Hey friends, so now we're gonna deep dive into something very powerful in Python. We're gonna talk about loops. So now let's start with the first question. What are loops? A loop is like a tool that we use to control the flow of our code. And if you use it, you are saying like, hey, I would like to repeat this code, this thing, over and over until I say stop, or something happened, maybe a condition is not fulfilled anymore. So now let's have a sketch to understand what this means. So now normally as we are coding, we write instructions one after another, and if you go and execute it, Python has to go from the top to the bottom, executing all your instructions one after another, and all your instructions will be executed from Python. So it is a straight line code, and that's great for simple stuff. But in reality, as you are coding, what could happen that you will notice there is like a block of code that keep repeating. It could be repeated like 5, 10 or even 100 times. That means we are repeating ourselves, and this is not really good because our code can explode. Instead, what we could do, we could put our code in autopilot. So what we can do, we write this block of code only once and then we attach it to a loop. This loop gonna go and execute the block of code over and over as long as the condition is true. So with that, you write your code only once and you repeat it as much as you need. And in Python and as well in many other programming languages, there are two main types of loops. We have the for loops and the while loops, and each type has different types and purposes. Now we're gonna deep dive into the for loops. So let's start. A for loop lets you go through a group of items one by one in order to do something for each item. So it's like you are saying, do something for each item in my list. So let's understand exactly what this means. So now we start in our code with the keyword for in order to build the loop. And once Python sees the for keyword, it's gonna go immediately behind the scenes and start building a logic, a process. So it has a start and as well a condition. And of course, this condition is not specified from us in the code. It is something that Python do once it sees for. So the condition gonna be always like this. Is it the last item? So it is actually asking, am I done? Is it the last item in the group of items? You will understand exactly what I mean with this once we have an example. And as usual, the answer for each condition could be either true or false. So this is what's gonna happen once we specify a for. Now, next we have to define the loop variable. So it's like a variable that we're gonna use to assign the current value of a sequence. You could name it whatever you want, an item, user, whatever. And then we use the operator in. And after that, very important, is the sequence. You define here the group of items that should be iterated. So with that, we give Python the list that we would like to iterate. And this is what we call a sequence. And now Python behind the scenes is gonna take this sequence and create it out of it an object in the memory called iterator. This iterator is responsible for knowing where we are currently in the loop and what is the next item in the sequence. So it keeps tracks on what is already done and what is next. So with that, we have now the setup, the configuration of our for loop. We know how we have to iterate 3 times because we have 3 items, but still we have to tell Python what to do, which line should be repeated, right? Of course, in order to do that, we have to do the double points and then go to a new line. And don't forget here the indentations. So we have to leave 4 spaces and then write the line that should be iterated. Like for example, it could be print the item. And now Python knows this block of code should be repeated. And this can be if the condition is false. So as long as we still have items, this code should be repeated. And of course, after the execution of the print, it's gonna go back to the start in order to grab the next item. And of course, if the condition is true, so we are at the end, Python gonna go and end the loop. And that means we can go and execute the next instruction. So now let's see how Python gonna execute this. So as usual, we start from the beginning and now it goes to the condition. It's gonna say, is it the last item? So Python gonna go and ask the iterator, what is next? And since we are at the beginning, it's gonna go and answer, okay, the first one is 1. So the iterator gonna answer Python with the value 1. And this means the condition is not fulfilled. It is not the last item. We still have values in the iterator. That's why it's going to go to the path of the false. Now it's going to go and execute our block of code, print I, and here Python assigns the value 1 to the variable I, and that's why we need the loop variable in order to assign the values that we are getting from the iterator or the sequence. And now once our code is done, it's going to go back to the start. And then what's going to happen, my friend, it's going to go and ask again, give me the next item. So now the iterator going to say, okay, we are done with the first item. Then it's going to go to the second item and return 2. So Python sees, okay, we still have values. That's why we are not done yet. It's going to go back to the print, and this time I is equal to 2, and it's going to go and print it in the output. And again, it's going to go back to the start and ask the same question. Are we done? Do we have anything next? Now the iterator say, okay, we are done with the 2. Let's go to the next one, the 3. So Python going to get 3. It is not done yet. It's going to go and print it in the output and again go back to the start. But this time, if Python asks the iterator what is next, it's going to see, the 3 is the last item in the group. So it's going to say for Python, sorry, we don't have anything else. You have to stop. Now, once Python gets the stop, it's going to say, okay, we reached the end. We have processed the last item. That's why this time the condition is fulfilled. And it's going to break the cycle and get out of the loop. So we reach the end. So as you can see, our block of code, the print I, is executed 3 times. We didn't have to repeat it 3 times in our code. We just build a for loop for it and it gets iterated. Again, it's like autopilot. And by the way, my friends, if you are enjoying this type of free tutorials where I'm sketching the concepts behind the scenes and showing the codes, and you would like to see more like this, then support the channel by subscribing, liking, commenting. This really helps a lot. So now let's go back. All right, now let's say that we have the following example that we are printing like rounds. So we are saying round 1, and then we repeat this like 5 times. So round 1, 2, 3, 4. So now let's go and execute it. You can see we are getting the exact same stuff. So everything so far static, of course. And of course, we are repeating the same code over and over, but just the only thing that is changing is the round number. Now, of course, this is not very smart because we are repeating the same code over and over. And instead of that, we can write our code once and then put it in a loop. So we can go and get rid of everything. And then we say for I, this is our variable. And then we define the sequence like this, 1, 2, 3, 4, 5. Now we go and add double points. With that, we have defined the structure of the for loop. We are saying let's iterate through this sequence, and then we hit enter. Now we have to be careful with the spaces. The indentations here should be 4 spaces, for example, and then we can go and grab our prints and put it over here. So now the print is inside the for loop, and now if you go and execute it, what's going to happen? Python going to go and repeat this code 5 times, and that's because in our sequence we have 5 values. So that means we have 5 items in our list, and Python has to go through them one by one, and with that we are getting the output. But we are not there yet because we are printing the same code. I would like to have the value of the sequence in the output as well. Of course, the value of the sequence are always assigned to the variable. So what you can do, you can go and use our string format, and then we have to go and replace this static part with the loop variable. So we don't need you anymore, and here we have an I. So now for each round, we will get the value from our sequence. Let's go and execute it. Now you can see we are getting the exact same output. So round 1, 2, 3, 4, 5, and those values are coming actually from the sequence. So it is very simple, right? You just have to define the loop and then tell Python what to do for each iteration. Now I would like to show you something like a rule for the naming of the variable and the sequence that we usually use. So for example, we could put our sequence in a variable called items equal to this value, and then we could use this variable inside our for loop. You can see items, but usually we're going to call it like this, for item in items. So the variable name is a singular and the sequence is going to be like plural for the same name. And it is really nice to read, for item in items. And if you have like tables, you could say for table in tables, for file in files. So this is really nice. Just use the same name as a singular for the variable and plural for the sequence. And of course, we can go over here and call item. And if you go and execute it, you will get the same results. It is really cool. You know immediately this variable here gets its value from the items. Now, there is something important to understand about the for loop, is that we have always to specify a sequence, a group of items that has a start and end. In the current example where we have the numbers 1, 2, 3, This is what we call a tuple. It is a data structure that we're gonna learn about it later, don't worry about it. But we could use as well other sequences. Like for example, we could use a list. A list is as well a sequence. Let's have an example. So now let's check that out. If we go and remove this and have the brackets at the start and as well at the end. So if you go and now execute it, you will get the same results. This is as well a sequence of numbers, and Python gonna treat it as a sequence. So we could use as well list in our example. And by the way, for example, let's go and remove the 5 and add a string value like hi, this. And now if you go and execute it, you will get the last one round hi. So there is no rule in the for loop that the items must be either be numbers or string values. You can go and do like a mix. Okay, the next one that we could use is a string. A string value, it might looks like one value, but actually it is a sequence of letters. So each character, each letter is actually one value. That means we can go and iterate through a string value. Let's have an example. Okay, so let's try this out. I'm gonna go and remove the whole thing over here. Let's have a value like Python. So this time we have like one string value and we're gonna go and iterate it. Let's go and check that out. Now, as you can see, each letter gonna be like one value, and Python gonna go and iterate through the whole string. And of course, if you have here some spaces, it's gonna be considered as well as a character. So you're going to execute it, you will get for the first round a space. So with that, you can see our string value is not only one value, it is actually a sequence of characters that has a start and an end. And you can use it in the for loop as a sequence. Okay, moving on to the next one. What else we could use in the sequence is that we can use a built-in function called range. So let's say that you would like to iterate like 100 times. It's gonna be really annoying to make a tuple with 1, 2, 3, 4 and like you define 100 values, right? Instead of that, we could use this built-in function range to generate a sequence of numbers. Now in this function, we can define many things. Let's start with the one that is very common. We specify a stop. So we use the stop to tell when it must stop generating numbers. For example, if you go and say range 5, the sequence will look like this. It starts with 0, 1, 2, 3, 4. So with that, the total generated numbers are 5. And you can see we don't have the number 5 in the output because otherwise it's going to be 6 numbers. And this might be confusing for many where they think if you add 5, you will see it as well in the output. Well, actually the stop will not be included because it starts from 0. So let's try this out. So now we have here again our sequence of numbers using a tuple. Now let's go get rid of this. And instead of items, we will use the function range. And we have to pass for it value. Let's pass the 5 and try this out. Now, as you can see in the output, we start with around 0, 1, 2, 3, 4. So this is really nicer instead of writing like 5 numbers, right? Now, if you go and say 100 and execute, it's going to be very simple. It's going to go and generate 100 numbers. And with that, you iterate our code 100 times. So now let's go back to our 5 example here and execute. Now, let's say that this is not what exactly I need. I would like to start from the round 1, not from 0. So how we can fix this? Now we could use in the range another argument. We could use the start argument. This is optional. If you don't specify anything, it's going to be always the 0, right? But now we want our start. That's why we can go and specify the start. Like for example, 1, and with that we are forcing Python to start generating from 1. So now if you execute it, we will get a sequence that starts from 1, 2, 3, 4, and then it stops. It will not include the 5 in the sequence because it doesn't include the stop. So by looking to this, the start will be always inside your sequence, but the stop will not be inside. So let's go and try this out. Now, if you go over here and say, okay, start from 1 and execute. Now in the output, it looks nicer. We are starting from the round 1 as we want, but we have the issue. We don't have any more than round 5. Now, in order to have it in the output, we can go and increase the stop to 6. So if you go and execute it, you will get the round 5. And we don't have the 6, of course. Okay, now moving on to the final argument that we can pass to this function, it is the step. It is as well optional, and we use it in order to define or specify the incrementation. If you don't include it, it's going to be always the 1. So we always increment our sequence with 1. So let's say that I would like to go and generate all the even numbers between 0 and 10. And now what we can do, we can specify the step 2. So now the incremental gonna be 2. Let's see what's gonna happen. So it starts from 0, and then the next generated number, it will not be 1 because the incrementation here is not 1, it is 2. That's why the next number gonna be 2. Then the next in the sequence gonna be 4, then 6 and 8. And now of course we will not have the 10 because the 10 is our stop. Now let's say that I would like to go and generate all the odd numbers between 1 and 10. So we're gonna have the same setup, but this time we start counting from 1. So now we start from 1, then the next one, 1 plus 2 gonna be 3, and then 3 plus 2 gonna be 5, 7, and then 9. And with that, we are generating odd numbers. So it looks nice. So let's try that out. I'm gonna go and add the stop 10 over here and execute. You see, we have all the numbers between 1 and 10. Then let's go and add the step 2 and execute. You will have only the odd numbers. So as you can see, the iteration is less than before because we are incrementing with 2. Now, if you go and say, let's, for example, 4 and execute, you will get only 3 numbers. So the step is bigger in the sequence. So far we are generating only odd numbers. Now let's say that I would like to start from 2 and end at 10, and the step should be 2. So if you go and execute it, you will get now even numbers. So it is very simple. With those 3 arguments, we can define exactly how the number is going to be generated. So this is how the range function works. So those are the famous sequences that we usually use, but you can as well use any other sequences, like for example the dictionary or maybe files. So any object in Python that is iteratable, you could use it in the for loop. Okay, so with that we have learned how to build a loop, how to build iterations inside our code. And now of course always the question is, why do we need those stuff? How to use the for loop in real projects? So now in the data world, usually we have like files or tables that are in one place, and we would like to go and move all those tables from one place to another place. Now imagine that you have to write a code for each table. So if you have like 100 tables, you're gonna write like the same code 100 times. Now instead of that, we can go and build a loop in order to go through all the tables one by one and start loading it to the target place. So we write the code once and we iterate through all tables. And of course it could be files as well. You might have like 100 files and you would like to move them from A to B, and for that we usually build a loop. Now if you are working with data, we might go and let's say clean up those files, those tables, and if it is always the same action that we would like to use, what we can do, we can use as well a loop. So we go again and iterate through all tables and do the same data cleansing. So with that, we are preparing the data before maybe analyzing it. Now, of course, not only tables and files, we can go and iterate through columns. So let's say that we have in our table multiple columns and they are bad quality in the values of the columns. Like for example, we have leading or trailing spaces. So of course, in Python, we could use the strip function in order to clean up the data. So now instead of applying this function for each column inside our code, you might have really big file or table with hundreds of columns. Instead, we make a loop for all columns and we iterate through all the columns of our table where we apply the strip function. So with that, instead of having 100 of lines, you have only 2 lines of code, 1 line for the for loop and the second one for the function. So as you can see, this can be like foundations for you as you are working with data. You use it in order to load data. We use it in order to do data preparations, data cleansing, and many other stuff. So the for loops are really amazing. Okay, so now I'm going to show you a few use cases where I use for loop. So we usually use it in order to do aggregations like summarizations, finding the average. So let's say that we have here scores, a list of scores, and here we have few values like 80, 50, 60, and 75. Now I would like to go and find the total of those scores. So we can go and create new variables in order to store the total score. And now in order to do the summarizations of all those values, we can go and use a loop. So we can say for, and then I need a variable. So it's gonna be score in the sequence scores. And of course, don't forget the double points. And now what we're gonna do? We're gonna say total is equal to the current total plus the scores. So we are accumulating the values we are getting from the loop and we are storing it to the total. And of course, as we learned in the operations, we have some shortcut in order to do this. We could add a plus before the equal and then just remove this. So I am adding the scores to the total, and now we can go and print few stuff. Like for example, we can say the current total and then we say the total. And outside of the loop, I would like to see that final total. So final total, and as well here the variable total. So let's go and try that out. We got an issue because this is wrong. You cannot use the scores, the sequence. You have to use the variable. So the score, not the scores. We use the scores only for the iteration. So let's try again. And now, as you can see, it is working. So first we have the current total 80, then plus 50, 130, 190, and the final total gonna be 265. So as you can see, we can use it in order to do some aggregations. Okay, to the next one. As we learned, we can do data cleanup, data preparations using for loop. So let's say that we have a list of files like this. So the first one gonna be reports.csv, and the next gonna be data.csv, and the third one final.txt. And let's go and add some evil white spaces on left or right in order to have some bad data quality. So now here we have two issues. We have the leading and trailing spaces, and as well, you can see we have sometimes lowercase and uppercase. Now I am a data engineer or analyst, and I would like to go and clean up the data before I do something about it. So here I have to do two things. First, removing the spaces. Second, making everything either lowercase or uppercase. So depends on the rule that I follow in my projects, I have to change the cases. So in order to do that, we could go and create a for loop. We're gonna say for file in files double points. Now, what are the action? We're gonna say file is equal to file dot, and we have now to start clean up the data. So we can start with the strip function to remove the white spaces. And now in order to test it, we're gonna go and print the results. So we're gonna say processing and then the variable name file. So now let's go and test this out. So now by looking to the output, you can see we don't have any leading or trailing spaces. So everything looks fine. And with that, we have cleaned up the names of our files. Now we are not done yet. We still have this lower and upper cases. Now we can go and add the second transformation. And I would like to say, I'm going to go and make everything lowercase. Now, if you check the output, it looks way nicer. Everything is lowercase and everything is following our rule. And another thing, let's say that I would like to go and get rid of the txt. Actually, we only allow CSVs. So in order to do that, we add another transformation and we say replace. Now the old value gonna be .txt and the new value, our standard, is CSV. Now it is very important you don't write it capitalized because we are doing this, the replace, after we made everything lower. So it's always like this. First, clean up the data and then do data transformations where you adjust and manipulate the data. The order is very important. First clean up and then manipulate. So now if you go and execute it, with that, the final is as well .csv. So this is really amazing. We write our data preparations only once, and then we build a for loop in order to iterate through all our data. And this is exactly the power of the for loops. And as a data engineer, analyst, scientist, you have to do a lot of data preparations in your pipelines, and you will end up using those for loops many times. So make sure to understand those concepts. They're going to be very important for you. And my friends, it is challenge time. So you have to go and print 7 times table from 1 to 10, but you must use a loop and it must look exactly like this output. Don't miss one character. Okay, so if you are done with this, I have for you a second challenge. You have to print the following left-aligned star pyramids. So the first line is 1 star, the second is 2, 3, and the last one should include 6 stars. And of course, my friend, you must use for loop for this. So go and solve that. Okay friends, now so far we have been looping through items using a simple way, very simple design. But now we're gonna level it up and we're gonna build and design an advanced loop. In Python there are like tools or add-ons that we can put in our loop in order to have more control, like when to stop, when to skip, and here I'm talking about the special loop statements. We have break, continue, pass. So let's start with the first one, the break statement. The break statement is used in order to immediately stop the loop. No matter where you are currently in the loop, you will exit, you will stop everything and go out. And once Python sees it, the loop ends right there and go to the next line of the code. So let's understand how this looks like. So now by looking back to our simple design of the for loop, you can see that Python can execute all the items inside our sequence without stopping at all from the start until the end. There will be no break, there will be nothing, unless of course your PC crashes. So everything gonna be executed. But now sometimes we would like to have a check. If a certain condition is met, we have to do something. So that means we have to build a condition using the if statement, and we have of course to do it inside the for loop. So let's say that if the item is equal to 2, something should happen. So now by looking back to our flowchart, that means we are building a second condition inside our loop. So again, the first condition comes from the for loop. It is something built in and we didn't specify it. But the second condition comes from the if statements that we defined inside the for loop. And of course, the answer could be false or true. So now we have to tell Python what can happen if the condition is fulfilled. Of course, you could like do something like print or call a function. But if you want to affect the iterations of the loop, we could use one of the 3 statements. So we could use break, continue, or pass. So now since we are talking about the break, if you go and use it, what's gonna happen? Python gonna put a break if the condition is true, and if this happens, everything gonna stop and Python gonna go immediately to the end. But if the condition is not fulfilled, everything is like before. Python has to go and print the item. Now let's see how Python gonna execute it behind the scenes. So it's gonna start from the beginning and ask for the next item. So that means we are not at the end of the loop and Python gonna continue. Now Python gonna ask the second question. Is I equal to 2? Well, it's not, because 1 is not equal to 2. That's why it's gonna go to false and Python gonna print 1 in the output. Then jump back to the top and again ask the same question. Are we done? Well, the iterator gonna answer with a value. We are not done yet, so that's why it stays inside the loop and go and ask the second question. Is I equal to 2? Well, this time yes, this is true. 2 is equal to 2 and that's why Python gonna go to the break statement. Now what's gonna happen once Python sees break? It's gonna destroy everything and stop everything. So there will be no more iterators and Python jump immediately to the end and it can ignore everything else. So with that, we didn't iterate through the whole sequence. So the iterator is not done and we have only one successful round, one iteration. But because we have fulfilled the condition and the break statements, everything stopped. And in the output, you will get only 1. So as you look to this, it's like we are building an emergency exit, right, from the loop. If something catastrophic or emergency happens, we have to stop everything that we are doing and get out. This is exactly how the break statement works in Python. Okay, so now let's have an example where we have list of names. So we could have something like John and Maria, and now we're gonna have something empty. So we don't have any value inside it. And then let's say Kumar. Now you can see we have 4 values, but one of them has an issue. We have here empty. Now let's just make a normal loop in order to print the names. So we're gonna say for name in names, and now let's go and print. So we're gonna say f name equal to our variable, so name. Let's go and execute it. Now as you can see, we have all the 4 values and the empty one even. Now let's say that if there is something empty in my data, I don't want to continue. I want to break the loop and to stop the program. So now in order to do that, we have to make a check. So first we're gonna say if name is equal to empty. So with that, we are checking whether then it doesn't have any value. Double point, and now we hit enter and print a message. Now as you can see, we are now at the second level of the indentation. Print is inside if, and if is inside for. You have to be careful with that. So we can say empty value detected. And of course, this is not enough. We want to stop everything. So we're going to write a break. And now very important to understand, the break must be inside an if. Otherwise, you will break from the first iteration. So now let's go and try this out. So now in the output, you can see we processed two values, John, Maria, and then once we processed the empty, this condition was true and we went inside it. So we printed the message empty value detected and then the break is executed. So that means we stopped over here and we didn't process those two values. So they didn't have the chance to be printed over here. So this is exactly what's going to happen if you use a break inside your for loop. Now let's go to the next one, the continue statements. We use it in order to skip one loop cycle. So that means once Python sees the continue, it's gonna stop right there. But instead of ending the whole thing, the whole loop, what's gonna happen, it's just gonna jump back to the top and start the next round. So that means it is not that catastrophic like the break where it's gonna stop everything. We are just skipping the current round and go to the next one. So let's have a very simple example to understand it. Okay, so now in our code, after the condition, this time, instead of using break, we will use continue. So now what's gonna happen behind the scenes is that if the condition is true of the if statements, we will have continue instead of break. But here comes the important points. After continue, we will not go to the end. We will just jump back to the top. So we're gonna have an arrow from continue back to the start of the loop. Of course, with that, we are not saying we are going to the beginning of the iterator. So we are not resetting anything. It is just simply we are skipping the current round. So let's try this out and see what can happen if you do that. Now Python starts from the top and ask the iterator for the next item. It's gonna be the first one, so the value number 1, and then go and ask the second condition is 1 equal to 2. Well, it is false. That's why Python gonna go to the right side and execute the loop as normal. So in the output, you will get 1 and then jump back to the top to repeat and ask the same question. What is the next item? The iterator answer with 2 and then to the second question, is 2 equal to 2? This time, yes, we have fulfilled the condition and Python goes to the left side and execute continue. Continue means skip the current one and just go to the top and go to the next round. So with that, we didn't do the normal iteration. So Python will not execute the print and you will not see the value 2 in the output. So we skipped the 2 because it is fulfilling the condition. And Python has to start again from the top and ask for the next item. It's going to be 3 and then ask the second question, is 3 equal to 2? Well, it is false. And then go to the right side to the normal loop. It's going to print the value 3 and then go to the top and ask for the next item. Well, we are at the end. The iterator asks Python to stop. So with that, the answer is going to be true and jump to the end of the loop. So as you can see now in the output, we have 1 and 3, but we skipped one round. So it's not like the break where we stopped the whole iteration and we stopped everything and went to the end. We just skipped one single iteration because it was fulfilling the condition. This is exactly what continue means. Okay, so now back to our example where we have the 4 names and one of them is empty. It was too much, that once we founded the empty over here, we stopped the whole loop because I would like to process as well Kumar over here. So what we can do, instead of having break, we can say, you know what? Just continue. I'll continue. And with that, we will skip only this one bad value, but we will continue the loop. So let's try this out and execute. As you can see in the output, we have now name is equal to Kumar. So we processed this value and we still see our message empty value detected, and this comes from here. So that means, yes, we found the bad data, but we skipped it. We didn't process it inside the branch. And with that, we guarantee we are processing only the good data. And in this scenario, I'm gonna say continue here is more suitable than break, because if I'm using here break, it is like an overreacting. I would like to process all other values. It is only bad value inside my data, and I would like to process all others. And since this is not really critical, I could go with the continue instead of break. So that's all for the continue statement. Now let's go to the third one. We have the pass statement. Pass is just like placeholder where nothing happens. So this sounds a little bit strange, but all what we are saying here that I will put here code later, but for now, just keep going, don't bother. What the pass statement means, for now, do nothing. So let's understand what exactly this means. Alright, now let's go and put pass inside the if statement. So that means instead of continue, we're gonna have pass, and this is gonna be executed if the condition is true. Now, of course, what is very important is where the arrow gonna go after the pass. Well, this time it will not go to the end, it will not go to the start of the loop. Well, actually, it's gonna go to our block of code. So it's gonna go back to the normal way of our loop. Now, if you look to this, do you see something strange? Well, it doesn't matter if the answer is false and true. Both of them are leading back to our block of code, right? So that means we are not stopping anything like the break, we are not skipping anything like the continue, everything gonna stay as it is. So the big question is why we need it. Well, we don't use pass very often in our coding, but we use it as a placeholder as we are planning the next steps. So for now in my code, I am sure that I have to check for this situation where I is equal to 2, but I still don't know what I'm gonna do if the condition is true. So it's like I'm planning something inside my code, I don't want to forget about it, and I'm building something temporary. And the final solution should not, of course, include pass. Now let's have a quick example to see how this can work. For the first value 1, well, is 1 equal to 2? The answer is false. Python gonna go and execute the print normally, and we will see 1 in the output, and then go back to the top and ask for the next item. You will get 2. Well, is 2 is equal to 2? This time we will go to the left side and execute the pass, and nothing gonna happen. Python has to go back to the print and print in the output 2. So you see, we are not skipping, we are not ending anything. Then go back to the top and ask for the third item. You will get 3 in the output like usual, and the next one, the iterator, will give you no value and ask for stop. That's why Python gonna end and go outside. So as you can see, it's like you are iterating without having the condition. You iterated through all the values 1, 2, 3. So again, pass means just keep doing what you are doing, keep doing the iterations, and maybe later we're gonna add something in this place. So it is like placeholder. Okay, so now back to our example where we have the 4 names and one of them is empty. So the thing is, this is yes an empty value, but I don't know yet what to do with it. I could go and replace it with dummy values like unavailable, unknown, maybe some flags, but still, I don't know what to do with this. And on the other hand, I don't want to skip it. I don't want now to break the whole program or skip this step. I would like to decide about this later. So what we can do, we can go over here and say, you know what, we're gonna make a pass. And then I'm gonna go and write a note for myself so that I don't forget about it. So I'm gonna say to do handle empty value, and to be honest, I don't want to print anything in the output because we don't want to see this yet. So it is just something for me that I would like to plan for the future, but at least I know about this scenario. I know there is like an issue like this, and I have already like a condition for it to check it, but I don't know yet the action. So now if you go and execute it, you can see we're gonna go and process all the names that we have in our list. So we are not skipping anything. Maybe after a week, I meet my team and then we discussed about this issue. I told them, yeah, we have like some empty values in our data and I would like to know how to handle it. And then we agreed all to have dummy value like unknown. So now I come back to my code and say, you know what, let's go and do it like this. Name is equal to name and replace. And instead of empty, we're gonna have unknown. So it is like this, and I can go and remove now the pass. We don't need it. I know the action and execute it. You can see now in the output, I'm getting the unknown. So we didn't skip, we didn't stop anything. We just prepare it for the next steps. And this is exactly how we use this statement pass in our code. So now let's have real examples on how to use continue and break. So the first task, it says loop through a list of days and print only the working days, skipping the weekends. So now let's go and create a list of days. So for example, let's have a Monday, Sunday, Wednesday, and let's have a Tuesday. Just randomly some days. So now we want to print in the output only the working days. So we don't want to see any weekends. And for that, we can go and create a for loop. So we're gonna say for day and days and then double points. And now we're gonna go and print the work day, double points, and then our variable day. That's it. Let's go and execute. Now in the output, you can see we are printing everything, even the weekends, which is not really what we want. So we have to check whether the day over here is a weekend. Now for that, we have to go and create an if statement, and we can say if day in, and then we're gonna have our two values, Saturday and Sunday. like this. Now, if this is the scenario, what can happen? Should we break or should we continue? Well, as the task says, we have to skip the weekend. We don't have to stop everything, yeah? So it's not that catastrophic. That's why we're gonna go with the continue. We want to skip those days, otherwise go and print the day. So let's try this out and execute. You can see we have Monday, Wednesday, and Tuesday, but the Sunday is not in the output, and that's because it is fulfilling our condition here. So as you can see, it's very simple. Why I decided for the continue, because I just want to skip, I don't want to stop. So now one thing quickly about the styling, as you can see again, I'm always using the same name. So day in days. And one more thing, try to not put a list in conditions or maybe in the for loops. So as you can see for the days, I always define a variable outside. And for this as well here, I'm gonna go and take it out and make a variable for it. So we're gonna say weekends, and we're gonna put it outside, and then over here we're gonna say weekends. So now as you can see, it is now nicer and shorter and easy to understand. For day in days, if day in weekends, so it is easy to understand, and you can here extend it outside easily than extending stuff inside the for or the condition. Then things gonna be easy to write and easy to read. So with that, we have solved the task. Okay, so now let's have the following task, and it says, scan through a list of email addresses and prevent unsafe data from entering your system. So now, as usual, we're gonna go and create some simple data. So emails like, for example, data@gmail.com, and another one, para@outlook.de. And then we're gonna have something strange like drop table users and semicolon. And then we're gonna have something like maria@gmail.com. So now let's say that I would like to process my data, and I'm gonna say for email in emails, and we're gonna print processing email and then double points and our variable. Like this. So now let's go and execute it. So now in the output, you can see we have processed all the emails, but actually we are not doing the job. The task is to check whether everything is safe. And my friend, this is not safe at all. We have here an SQL injection. SQL injections, it's one of the most famous hacker attacks on your applications that could happen if you have any field where the user is entering data. So maybe in the registration form or in the sign in, you have a field to enter the emails, and with that, the hacker is going to use it in order to add an SQL injection to destroy your database or maybe to read important informations. And actually, it is one of the easiest way in order to hack your system. That's why most of the systems must protect their data and their applications from those SQL injections. Now we can go and check whether the email includes a semicolon. Semicolon is indicator that there is an SQL statement, there is a command. So we can go and check for that for say, if we have a semicolon in email. So what can happen? We're gonna print, and we can say something like this, SQL injection and hacker attack. So with that, we get some panic. Let's go and execute it now. Now you can see in the output, we are getting the message, right? But still we are processing it, which is really bad. We have to add here a control flow statement. So again, continue or break. Well, I would say I will not trust the data at all that I'm getting from this source. That's why I'm gonna stop everything and I'm gonna go and use a break in order to protect my system. So with that, as you can see, we are processing only the first two emails and everything else gonna be stopped. As you can see in this example, we have high critical risk in our system and we use break in this scenario. Now let's have a quick recap and compare them side by side. The first statement is the break, where we add a condition, and if this condition is fulfilled, we execute the break and we exit the loop. So you are building like an emergency exit if something goes really wrong. That means all other values will be totally ignored. We have to exit immediately.
Oh my God! Okay, it's happening. Everybody stay calm.
What's the procedure, everyone? What's the procedure?
Stay calm!
We usually use this only for high critical risks, like for example, security issues. As we learned about the SQL injections, if you encounter this, then you have to stop immediately, otherwise you might destroy your system. Now moving on to the next one, to the continue. This one is not that dramatic. If the condition is fulfilled, we're gonna say just skip this iteration and go to the next one. We will not stop the loop. And of course we use this for medium risk cases like empty data, bad rows, empty files, and any other weird special cases that you might encounter, and you say, okay, just skip it. Now finally, to the chilliest one of the three, we have the pass. So for this one, if the condition is fulfilled, it's gonna say, you know what, just keep doing what you are doing, just execute the code and do your loop, do your thing. So it is like a placeholder, and you say, you know what, I have planned for this, but for now, you know what, just keep walking. Don't skip, don't stop anything. So again, break if you have something critical, go out now. The continue if you have a medium risk, and you say, skip this one. And the pass, it is just for the planning, and you say, do nothing. Hey friends, so now we're gonna talk about how to use the else statement inside a for loop. So we use the else statement in order to run a block of code only if the for loop finishes naturally, normally, without hitting a break. So all what we are saying here, okay, I went through the whole loop without any interruptions, and at the end, I'm gonna do something extra. So let's understand what this exactly means. Now, as you remember, we used already an else statement, but together with the if statement, as we are building the conditional logic. So we use the if statement together with the condition, and if it is true, then we print, for example, okay. And then after that, we said, okay, if it is not true, we could use the else statement in order to define what can happen if the condition is false. And for example, we say print not okay. So with that, we use else in order to define what can happen if the condition is not true. And then based on the execution, either we go to the right side or to the left side. But now if you look to the for statements, we said, okay, we have a sequence and we're gonna repeat the same code multiple times until we don't have any value. And once the loop completed and we went through all the items, then we go and exit to the end. Now, if you look to this, you can see after the loop ended successfully, we don't have anything to do. It will just go and exit. But now instead of that, what we can do, we can add an else statement. So we put it outside the for loop. It's like you are doing if else, and then you define what can happen. Like for example, print end. And with that, we have defined an action that's gonna be executed once the loop is completed. So as you can see, it is not exactly like the if else statements. In the if else, we went either to the right or to the left. With the for else, we're gonna do everything. We're gonna iterate through the whole loop, and as well at the end, we will be executing the else as we are exiting to the end. So now let's go deeper in order to understand how this exactly works. So again, we have this example where we have the three values. And now we add an else statement where we print an end. So this block of code can be executed if we reached the last item. So now if you go and execute it, the usual gonna happen. So Python gonna ask, okay, what is the next item? We will get 1, and then we're gonna go and print it. Then ask again to the next item, we will get 2, then print it again, and then to the last iteration, and then it's gonna go and ask again for the next item. We will get 3 and print it in the output. As you can see, so far we didn't execute yet the else statement because we are looping. Now gonna go back to the top and ask again, what is the next item? Iterator gonna say stop because we don't have anything left, and now the condition is true. That means Python gonna exit the loop, but before going to the end, we still have an else statement. So Python has to execute now the else, and we will get in the output an end. And after that, it can go to the end and stop everything. So as you can see, Python executed the else statement at the end after it went through the whole loop and iterated through all the values in the sequence. So this is exactly how the else statement works with the for loop. And by the way, my friends, if you are enjoying this type of free tutorials where I'm sketching the concepts behind the scenes and showing the codes, and you would like to see more like this, then support the channel by subscribing, liking, commenting. This really helps a lot. So now let's go back. Okay, so now let's have a very simple example. We're gonna go and create a classical for loop. So let's go and create a few items like numbers 1, 3, 4, and 7. And then a very simple loop. So for I in items, and in the output we will print the I. So let's go and execute it. As you can see, we have printed all the values in our sequence. So nothing fancy so far, but now what we can do, we can go and add an else statement. So now let's go to a new line, and be careful, you have to place the else at the same level as the for, not inside the for loop. So we're gonna say over here else double points, and let's print something like loop is completed. Now let's go and execute it. Now as you can see, at the end of our iteration we have this nice message saying loop is completed. So this is actually how you add an else statement to your loop. But here we have an issue. Our code now makes no sense at all, because what we are doing here, we are looping through the items, and at the end we are printing a message. Well, actually the else here is totally useless, because what I can do, actually I can go and remove it, and it's just simply like an instruction after the for loop. So after Python is done with the loop, just go and print the loop is completed. So if you go and execute it, you will get exact same results. So actually having an else like this is totally pointless and has no sense. And now of course the question is, if this is useless, then why we have an else statement in the for loop? Well, my friends, there is only one scenario where the else statement makes sense. If you combine it with the break statements, you have to combine the break and the else in order to have a real usage for the else statements. So let's understand what this means. Okay, so now again back to our example, as we have a normal for loop with a break. Now if you go and add an else statement at the same level with the for loop, and we say for example print end, so with that we are adding a block of code if we reached the last item in the loop. So if this is true, then print the end and then exit. So now let's see how Python can execute it. As usual, Python can ask for the first item from the iterator, we will get 1. Then it's gonna check the condition, is 1 equal to 2? Well, it is false. That's why it's gonna go to the print and print 1 in the output. Then it's gonna go back to the top and ask again, give me the next item. It's gonna be 2. Is 2 equal to 2? Well, this time our friend is gonna be true. And Python gonna go to the break statement and exit the loop, exit everything. And with that, my friend, you will get in the output only one value, the 1. So Python didn't execute the next value in the iterator, the 3. And very important, Python didn't execute the else statements. And that's because, my friend, the condition last item was never fulfilled. We didn't get through. That's why Python didn't have the chance to go and execute the else statements. And this is exactly why we need the else statements. We use it as an indicator to understand whether we iterated through all the items or we encountered an interruption. So as you can see, the break and the else statements, they work together in order to define this logic. So actually it looks like this now. We have a for loop, and we want to repeat something over and over until the loop is finished. And once the loop is completely successful, we do something else using the else statements and then go straight to the end. So this is the normal flow if everything goes okay. Otherwise, we can go and build an if statement that we're going to check in each iteration. And as long as this condition is not fulfilled, we stay in the loop. But if this condition is fulfilled, then we make a break in order to exit the loop and then go straight to the end. So now as I am drawing this, the break statements really work hand in hand with the else statements, and they look like exactly the if else statements. So either the loop is completed and we execute the else statement, or the loop is actually broken and we are exiting using the break. So now really I understand now exactly why we are saying else, because either it's broken or else it is completed. And this is exactly, my friends, why I love doing visuals, because I understand then the logic, how things works. And this is exactly what I do usually. I draw the logic and then start coding the solution. So now back to our example where the else statement is totally useless. Now we're going to make a usage of it. I would like to go now and build a check to understand whether in my list we have an even number. And if we don't have any even number, then we have to print in the output that all the numbers are odd. So we have to go and make a very simple if statements, and we're gonna say if the remainder when we divide the item by 2 is equal to 0, then actually we found an even number. So we're gonna go and print something like this. Instead of the I, we're gonna say even number found, and then we're gonna go and print this item. Now after that, we're gonna go and break the for loop, and if we didn't find any even numbers, that means all the numbers are odd. So we're gonna say all numbers are odd. So as you can see, it sounds like an if else statement. Now let's try this out and execute. You can see even number found, and we have the for. Let me just add here a double point. So what happens here, that Python did check the first number 1. Well, it is not fulfilling the condition and nothing happened. Same thing for 3. But for the 4, we have it true. That's why Python did execute this block of code. So it printed the message and then executed the break. That means everything stops. And in this scenario, Python will not execute the else statement. Again, the else statement is going to be executed if Python did manage to iterate through all the items completely without hitting the break. So that's why in the output you don't find this message over here. Now let's go and test something else where we're gonna have all numbers are odd like this, so we don't have an even number, and then execute. You can see in the output we get all numbers are odd. So that means Python did try all those numbers and none of them fulfilled this condition over here, so it didn't manage to execute the break. That's why the loop was completed and Python didn't execute the else statement. So now, as you can see, the else statement here is totally useful. We use it in order to understand that Python did iterate through all the items and Python didn't execute the break and we didn't have any interruptions. And as you can see, it only works if you combine it with the break statements. And now we come to the question that why do we need those stuff and when we're gonna use it in real projects? Well, the main use case is that we use it in order to search and validate our data. As we are getting new data, we have to search for bad data and report at the end whether everything is clean or whether we found some bad data and bad quality. So let me show you now some real use cases. Okay, so now let's have an example. Let's say that I have a list of names and I would like to check whether we have any missing values. So let's have a very simple list of names, like for example, Kamara, and then Tuba. And the third one is actually missing. We have a none. And then the last name gonna be Monica. Okay, so now I would like to go and check whether we have any missing values. For that, we have to go and iterate through the list. So we have to go and create a for loop, for name in names, double points. Now we're gonna go and build a condition in order to check whether the name is empty. And for that, we're going to use an if statement. So if the name is none, then what we're going to do, we're going to go and print a message. We're going to say found a missing name. And after that, we don't want to continue. We have already found an issue in the data, and that's enough for now. So I want to stop and exit the loop. Now, let's say that we have checked all the names and we didn't fulfill this condition. So we didn't find any missing values. Now I would like to print a message saying that everything is okay. And for that, my friends, we use an else statement. We're gonna say all names are available. Okay, let's try this out and execute. And now in the output, you can see you found a missing name. That means it is working because we have here the third value as a none, and this made our condition fulfilled and activated the print found missing a name and as well the break. Now let's try another thing, like for example, we go and add a name here like Maria. And then let's go and execute. You can see in the output we are getting all names are available because all names are there and this condition is never fulfilled. And since we iterated through all the values of our list successfully, we got at the end this print message from the else statement. So as you can see, we are using the break together with the else statement in order to search for something and validate our data. And this is something that is very common as you are doing data quality checks and quality assurance. Okay, so now let's have another example where we use this. Let's say that I would like to check whether all my files are CSV. So that means we have to validate the type of the file, and this is something that happens a lot as you process files. Okay, so now as usual, we start with an example. Let's have few data. Like for example, we have a file name called data1.csv. Another one, we have report.maybe PDF. And a last one, let's say that's report2.csv. So now, as you can see, not all my files are CSV. We have one of them as PDF, which is not really good. Now we have to check that. So we're going to go and create a for loop for file in files. So now we're going to go and create our checkpoints, and we are checking the files. What we are searching for is actually the last characters of each string. So that means we're going to go and use the methods ends with. And we have to pass for it our expectation. So it's going to be .csv, but actually we are searching for bad data. So that means we have to search whether the file does not end with CSV. So we have to add the not operator. So what happens if your file is not CSV? First, we're going to print a nice message, and we're going to say, for example, let's print the file name. So the file is not a CSV. After that, we want to break. So we found something that is not correct and we end the loop. Now, otherwise, if everything is fine, we have to just print successful message. So else print all files are CSV. So now let's try this out. As you can see, we are getting report.pdf is not a CSV, and that's because it is fulfilling this condition and this block of code is executed. Now let's try the other one. So if you remove the PDF to CSV and execute, you can see all the files are CSV. So as you can see, again, we use the break together with the else in order to check the quality of our data. And now there is like one thing that I would like to show you. If we say, okay, this is a PDF and we have another one, let's say it is data2.txt. So we have two cases where it is bad. Now, if you go and execute it, as you can see, we are getting in the output only one. So report.pdf is not a CSV. So once we cached the first issue, the Python gonna break the loop. So actually we are not getting the second file over here, and that's because the loop stops. But now if you say, you know what, we can get as well the second one. If you remove the break and you say, you know what, let's go and use the continue. Well, let's see what's gonna happen if you do that. And now if you are looking to the output, now we are getting the two files, report.pdf and data2.txt. But the issue, we are getting this as well. All files are CSV, which is not correct. So actually this makes no sense. And that's because you cannot combine the continue with the else. It's gonna work only if you use break. So the continue, what's gonna happen, it will just skip one iteration. It will not stop the whole for loop. So actually you cannot do that. It makes for me no sense. You have to go and use a break over here. And with that, you will get only one file. If you are not happy about it, you can just go and say here, not all files are CSV. And then execute it. So that we are not reporting as well where we have the issue. So this is how we work with the break and the else statements with the for loops. And now, my friends, as usual, I will not leave you without a challenge. And we have a tricky one. So the challenge says, check the following list of file names and find out whether we have duplicates or not. So if you found duplicates, you have to tell us about it. Otherwise, if everything is fine, just say all files are unique. Now, I'm really interested to see how you're gonna solve it. So let's go. Alright friends, so now we're gonna talk about something called nested for loop. A nested for loop, it is very simple. We have a loop inside another loop. So that means we have a big loop, we call it the outer loop. And for each run of this big loop, we're gonna run completely a smaller loop. And we call this one an inner loop. And once this small loop is completed, we go to the next iteration of the outer loop. And the same thing gonna happen. We're gonna run again completely this small inner loop. And again, once the smaller one is completed, we run one more iteration for the bigger loop. And of course, we can keep nesting loops inside another loop. So we could have like very small loop inside the middle one. So this is exactly what we mean with the loop inside another loop. So now let's see how we're gonna build it. Now we have this classical for loop, nothing fancy, we are just iterating through a sequence. Now in order to make a nested loop, we define a new for loop, but inside the first one. So for example, for y in a sequence like 1, 2. And let's call the first one an x, so it sounds better. And with that, we are iterating through two loop variables, the x and the y, and we are printing both of them, the x and the y. Now about the chart, Python has like two loops, so they are connected like this, but we are not finished yet. Once we reach the end of the second loop, it will go back to the start of the first loop. And of course, once everything is completed, we will go to the end. So as you can see, the start and the end of the second for loop is actually completely connected to the first loop. And again, we call the whole block as the outer loop, and the block of code that is inside it, we call it an inner loop, so the second loop. Okay, so now once you execute it, Python has to go and create two iterators, one for the outer loop and another one for the inner loop. So now Python start with the outer loop and ask for the next item, and iterator gonna answer with 1. Since we are getting a value, we are not at the end. That's why Python now has to go and start the inner loop. So here Python gonna ask for the next item in the second iterator in the inner loop, and here as well we will get 1. So since we are getting a value, we are not at the end, and now Python has to go and finally execute the block of code print. So now in the print, the x is assigned to 1, the y is assigned to 1 as well. That's why in the output you will see 1, 1. And now Python will go and start from the top of the inner loop, and it's gonna ask for the second item of the inner iterator. We will get 2, and since we are getting value, we are not done yet with the inner loop, so it's gonna go and print. So the x is equal to 1, but now y is equal to 2. That's why you will see in the output 1, 2. So now it's gonna go to the top of the inner loop and ask, give me the next item. Now the inner iterator gonna answer with a stop because we are at the end. So with that, Python gonna go and exit the inner loop and go to the end. But of course, we are not at the end actually. We will go to the top of the first loop. So everything that we have done so far, that was only for the first item of the outer loop. Now Python gonna go and ask the outer iterator for the next item. It's gonna be 2, and guess what? 2 is not the last item of the outer loop. That's why it's gonna go and start again completely the inner loop. So the inner iterator gonna answer with 1, and you will have in the print now x is equal to 2, because the outer loop has the value 2, and the y is 1, so you will have 2 and 1, and then the next value 2, 2, and the inner loop gonna be done. Then exit again the inner loop, but you have to go again to the top of the first loop, and the same thing happen. You will go to the third value, do the whole inner iteration, and then go back to the top of the loop. So as you can see, this is the third time we are executing the inner loop. And now Python gonna ask for the outer loop. Give me the next item. The iterator gonna say stop, I don't have anything left. And finally, you will exit the outer loop and go to the end. And now we are at the end of the outer loop and everything stops. So this is exactly how Python executes the nested loops. And by the way, my friends, if you are enjoying this type of free tutorials where I'm sketching the concepts behind the scenes and showing the codes, and you would like to see more like this, then support the channel by subscribing, liking, commenting. This really helps a lot. So now let's go back. Okay, so let's have a very simple example. We're gonna start with the outer loop for x in range. Let's generate, like for example, 3 numbers. This is our outer loop, our big loop. Now inside it, we can add another loop. So for y in range, and this time for the smaller one, let's go with 2 iterations. So 2 numbers. This is our inner loop. And now we're gonna go inside the inner loop and print. So I'm gonna print, for example, between 2 parentheses, we're gonna have the first variable, the x, and then separated with a comma, and then the second variable. So something like this. Let's go and execute it. Now, as you can see, for each value from the outer loop, we have 2 rows. So 0, 0, 0, 1, then 1, 0, 1, 1, and for the last one, 2, 0, 2, 1. So that's it. As you can see, very simple. This is how you can nest 2 loops inside each other's. And of course, you can go and add a third loop, like for example, for z in range, let's add as well 2. So now we have to be careful. This print should be inside the third for loop. And here we're gonna go and add our third variable, the z. So now let's go and execute it. Now, as you can see, we are getting like a matrix of numbers. So as you can see, we have a loop inside the loop inside the loop. This is really easy. Okay, so now we come to the real talk. Why do we need those stuff? When we're gonna use nested loops in our data projects? And for that, we have actually two major use cases. The first use case is for crossing and combining our data, or we call it pairing the data. So it's all about, we have two different lists, and I would like to see all possible combinations of those two lists. So that means I'm going to go and combine and pair each value from one list with the other values of the other list. Okay, so now let's have an example where we have two completely different lists. The first one going to be the colors. So we have red, we have blue, and green. And another list, it is about the sizes. So we have stuff like maybe L, M, and S. Now let's say that I would like to go and generate maybe a product catalog with all combinations of colors and sizes. So I want to pair each color with each size. Now, in order to do that, we can use the nested loops. And here it doesn't matter where you start. Like, for example, let's start with the colors. So for color in colors. Next one gonna be about the size as an inner loop. So for size in sizes. Now, all what we have to do is to go and just print those two variables. So print, where we're gonna have something maybe like this. Maybe the first variable gonna be the color, and then after that I'm gonna say size, and we have the variable here size. So now let's go and execute it. As you can see, for each color I'm getting all the sizes. So for the red, the blue, and the green. So this is what we call sometimes Cartesian or cross or combining the data, where you pair all values with all values. So this is a nice use case for the nested loops. Okay, so now moving on to the second use case, and the most important one. We use it in order to go through layers, or we call it drilling into hierarchy. Let's have this sketch to understand this. Okay, the first example is that we have hierarchy in the dates. Like for example, we start with the years 2026 and 2027. Now for this we could make a for loop in order to iterate through all the years, and this we consider as the first level. And now we could drill down into more details if we go to the months. So that means we add another loop inside the year for month in months. So we are at the second level. Now we can go deeper where we go to the days. We are now at the lowest level, at the level 3, where we add a third loop where we say for day in days. And after that we have to go and do something about all those three informations. So as you can see, we are using nested for loop in order to go through different layers in order to drill down into hierarchy. Let's have an example. Now let's have an example. Let's say that I have to go and create multiple reports for each year, for each month, and as well for each day. And now instead of doing it manually, we can go and create for loops. So as usual, let's go and create our data. We're gonna start with the years. So let's say 2026 and 2027. And the next level is gonna be the months, where let's say that we have only two, for example, January and February. And the last level, the days, I will go and generate it using the range. So it starts with 1 and ends with, 29. So now I have all my data, and all what you have to do is now just to go and create the for loops. So the first one gonna be for the years, for Y in years, the next one for M in months, and the last one for the days for D in days. Now we have our nested loops, the three loops, and all what you have to do, for example, let's go and just print the file name. So it's gonna be F, and the naming convention starts with report underscore, and then the year. So I'm gonna go and get the variable of the year, then the month, so the M, and the last one gonna be the day, D, and as I said, we are creating CSV files. So actually that's it. Let's go and try this out and execute. So now in the output, we're gonna get a huge list because we have here a lot of days. So we are gonna have all those file names that combines the year, month, and days. And of course, we're gonna learn later how to create files, but for now we are just printing it. So look at this, with just few lines of codes, you can generate massive amount of data, and as well, you're gonna save a lot of manual work. And this is exactly why we are learning about the loops. And another example for this use case, and this one is very common as you are working with data, we navigate through tables and columns. So if you know some database concepts, you know that we store our data inside tables, columns, and rows. So the table gonna be the highest in the hierarchy, and if you drill down to the next level, you go to the columns. So each table contains multiple columns, and now if you want to go deeper, you go to the rows, to the actual data. And in order to navigate through this hierarchy, we could use nested loops. So for the first level, we could have like for table in tables. Then we drill down to the second level for column in columns. And then to the last level where we say for row in rows. And at the end, as usual, we have to do something like maybe cleaning up the data, doing different preparations and manipulations to the data, depends on what you are doing. And this setup you see now, those 3 different nested for loops, it's something that you're gonna do in each data project. So if I open now my project, I'm always gonna see those combinations where I'm iterating through the tables and then the columns and then the rows and then doing something. So now I'm gonna show you an example that I just used in my project last week, and I was running an SQL query on multiple tables and columns just to check whether we have nulls in the tables. And now of course we will not talk about the SQL query itself. It's all about that I had a huge list of tables and columns, and if I'm gonna go and write those queries manually, it's gonna take really a lot of time. Now instead of that, I just wrote a few lines of codes in Python and it solved the task. So let me show you how I solved it. It is very simple. First, we're gonna go and create a list of all tables that we are interested in. So let's say we have the customers, we have orders and products. So here we make a list of all tables that I would like to query. And here, for example, the prices. Then next I need the columns that actually I am checking. So we're gonna make another list for the columns. And here I was checking only for the IDs and the creation dates. So those 2 columns are actually part of all my tables. And then I made really nice 2 nested loops. So I said for T in tables, for C and columns. And now what we're gonna do, we're gonna take the query over here and add for it the variables. So I just made a print and then we start writing the query. So select count star from, but now instead of saying customers, I would like to get the variable from the list. So instead of this one, we're gonna have the dynamic table name. It's gonna be the T. And after that, we have the static parts, we have the where, and then we have the column name. And again, I will not make it static. I'm gonna go and get it actually from my list. The last part is actually static, so is null, and then the semicolon. So as you can see, I have converted my query into a dynamic query. Now let's go and execute it. As you can see in the output, I have automated everything. I got all my queries, and for each table we have 2 queries, one for the ID and another one for the create date. And with that, I don't have to write anything anymore manually. I could just make a few lines in Python in order to automate the whole job. And if I got in the future more tables and columns, I'm just gonna go and extend it over here and then automatically generate my SQL query. And I know this sounds really simple, but this is what advanced data engineers actually do, especially if they are building systems like data warehouse, data lakehouse. We will be dealing with a huge amount of tables and columns, and you cannot go and hard code everything. So you have to load the tables from A to B. You cannot go and script something for each table. Instead, we build something called metadata driven pipelines. We do exactly what we have done in this example, where we write the metadata, table names, the columns, and as well the data types and so on in variables and key values. And then we make a script like this over here where we iterate through the metadata and we do something like maybe copying the tables, changing the schema, doing few preparations. And with that, you will be saving as a data engineer or maybe as a data analyst if you are doing something huge in many tables. You save, my friends, a lot of time, and I use it many times in my projects. So I know we are talking about the nested for loops, but this is something very advanced and they're gonna make your work highly automated. And another example about hierarchy in real data projects is that if you are working with data lakes, like for example, if you are storing data in Azure, you might have like some containers, and inside each container there will be different folders, and inside those folders you're gonna find different files. And of course, my friends, we use nested for loops in order to navigate through this hierarchy so that we reach those files and then we load them maybe to somewhere else, or we do some transformations. This is something that you're gonna do a lot if you are analyzing those files or you are doing some data engineering about it. Of course, there are many other examples that you're gonna encounter, but the rule is very simple. If you have different layers, different levels, and you have like hierarchy, you will end up, my friend, using nested loop in order to navigate through the structure. So those are some real use cases about the nested loops. Alright friends, so with that you have learned how to build a nested for loop, and with that we have covered everything about the for loops in Python. Hey friends, so now we're going to talk about the second type of looping in Python. We're going to talk about the while loop. So what is a while loop? We use it in order to repeat the same code over and over as long as a condition is true. So this sounds like the for loop, right? Now, what are the differences between for loop and while loop? Here's the deal. With the for loop, we have understood that Python gonna go and create internally an iterator and as well a condition that keep checking whether we are at the last item of the iterator. And as long we have values from the iterator, we keep looping through the for loop. And once we don't have any more values, we go to the end. Now, there is like two issues with this setup. The first one is that we are always predefining the sequence. So before we start iterating, we know exactly that we have here 3 iterations. So it starts with the 1 and ends with the 3, and we know we're gonna iterate 3 times. So we know exactly how many times we're gonna iterate. The second issue is that this condition in the middle is as well something predefined from Python and we cannot change it. So it's always about whether we are at the end of the sequence. And this is exactly why we have the second type of looping. We have the while loop. So this time we're gonna define our own condition for the iteration, and if our condition is true, then we're gonna go and do something and go back to the top. So that means as long as our condition is true, we will keep looping and iterating. But the moment our condition is not anymore true, it is false, then we're gonna exit the loop. The big advantage is that we define our own loop. So with that we have more freedom and flexibility, so we don't know upfront how many times it will go. It is all about our condition, and this sounds of course risky because we might end up easily in an infinite loop. So now by looking to those two side by side, the difference is very simple. With the for loop, we are iterating over a sequence like a range, a list. So we are looping over something known. But with the while loop, we are iterating and looping over a condition that could change anytime. So now let's dig deeper into the while loop. Now for the while loop, we have as well, like the for loop, different designs and types, and I'm gonna put them into 2 categories. The first one, we call it the while condition. So you define a condition and the loop can keep going until the condition becomes false. So this is the classical type, but we have another design, we call it the while true. So this loop gonna run forever, it is infinite. That's why we add to it together with a break statement in order to force the loop to stop. And of course, there is a reason for that. So those are the 2 main categories, and we're gonna start with the first one, the classical one, the while condition. So now we're gonna start with a very famous use case where we build a counter using the while loop. We start with the keyword while, and then we define a condition like, for example, I should be smaller than 4. And once you do that, Python gonna go and create for you a condition. And as usual, for each condition, we have either true or false. Now, since this is a while loop, false means we're gonna go to the end. But if it is true, we need to do something. If something could be like, for example, print the eye. Now, if you do it like this, after the action is done, it's gonna go back to the top of the loop. So it is like 2 lines similar to the for loop. If you go and execute it, you will get an error because Python don't know what I is. So we have always to assign it first to a value before the loop. And of course, we call this initialization of the while loop. Now, once you do that, it's gonna put it, of course, before the loop starts because we are outside of the loop. So now let's see how Python gonna execute it. First, it's gonna go and execute I is equal to 1. So it's gonna create a variable and assign for it the value 1 and then enters the loop. So now it's gonna go and check, okay, is I smaller than 4? Well, it is true. That's why it's gonna go and print the I in the output and then go back to the top of the loop. And then ask again, is I smaller than 4? Well, nothing changed, my friends. The I still equal to 1 and it's gonna fulfill the condition and then gonna go print it again and go again to the top of the loop and gonna ask again, is I still smaller than 4? Well, of course. So as you can see, it's gonna keep looping. We are stuck in infinite loop because we never changed the value of I. And the condition is always true. That's why it will never stop until it kills your PC. That's why we have to add a new line inside our while loop in order to give a chance for the I to change. Like for example, we could update it by adding 1 to the value so that the value get incremented by each iteration and we have like a counter. So now let's see how Python gonna execute it. First, it's gonna start with the initialization. So it's gonna assign 1 to the I and then it's gonna go and enter the loop. It's gonna go and ask, is I smaller than 4? Well, it is true. That's why it's going to go to the print and print the current value is 1. Now next Python going to go to the second step and add the value 1 to the variable. So 1 plus 1 we will get 2 and then assign it to the variable I. Now I'm going to go to the top, but this time we have a new value for the I. So is 2 smaller than 4? Well, it is true. That's why it's going to go to the print it in the output 2 and then update the value again. We're gonna have now 3 in the variables and then go back to the top. Is 3 smaller than 4? Yes. Go print it in the output and update it. So now our variable is equal to 4 and then go back to the top. Now it's gonna ask, is 4 smaller than 4? Well, this is false. And finally, now Python is gonna break the loop and go to the end and exit. So as you can see, Python will keep looping and iterating as long as our condition is true until the condition change and turns to false. And this is the only way to exit our loop. And this is how we build a counter in Python using the while loop. So now if you look again to the code, we have here 3 sections. The first one, outside of the while loop, we have something called initialization, where you define the initial value of the loop variable. And then after the while, you define your condition. And now inside the loop, you do the thing that you want. But the third component that is very important, so you have to build an update mechanism. So you have to change the value that we are checking in your condition. So if you don't do those 3 steps, either the loop will not work or you will be stuck in infinite loop. And by the way, my friends, if you are enjoying this type of free tutorials where I'm sketching the concepts behind the scenes and showing the codes, and you would like to see more like this, then support the channel by subscribing, liking, commenting. This really helps a lot. So now let's go back. So now let's build a counter that's going to count from 1 to 5. Let's start first with the variable, the initialization. So we're going to assign for it the 1. And after that, we're going to go and build our while loop. And now we're going to build our condition. So as long as the counter is smaller or equal to 5, we have to iterate and loop. So we're going to say, okay, print the count. And now the last step we don't have to forget about, making the update mechanism. So we're just gonna go and add a 1 for it. And actually that's it. Let's go and execute it. Now if you look to the output, you can see we have a counter that counts from 1 to 5. So with that we have a nice counter, and of course we can control now with those values the whole counter. We could make the step of 2. So now if you go and execute it, you will get in the output 1, 3, 5. So we have now bigger steps. Or we can say we're gonna count until 10, not to 5. So with those values we could control the whole counter, and this is what we call counter-based loop. Okay, now let's take things to the next level. Now look to our loop variable over here. This variable is getting the value from our code. It is something hard-coded and it starts with the 1. So there is no surprise how things can work over here, but we can make things more dynamic where we ask the user for a value and then we check it, and based on the user's input, we decide whether we continue in the loop or we exit. Like for example, you are building a system that asks a very simple question to the user. Do you agree? And the system gonna expect from the user only yes. nothing else. So if the user answers like no, maybe, or I will think about it, it will not accept it. We accept only yes, only if you agree with the system. So it sounds a little bit like the system is interrogating a user and it only accepts yes. So now how are we gonna do it? First, let's go and build a variable like the answer, and at the start it's gonna be empty. So now let's go and build a condition like this with a while loop, where you're gonna say if the answer from the user is not equal to what I want to hear, the yes, then ask again. And in order to ask, actually, we're gonna go and use the function input in order to get a value from the user. And you're gonna say, do you agree? And then we're gonna give the answers yes or no, then double point. Actually, that's it. That's all about the loop. We will not make anything incremental. So all what we are doing is we're gonna ask the user for a value, then we're gonna evaluate it. If it is not equal to yes, we keep asking. So the system gonna end up in infinite loop until it hears yes. Now let's go and maybe print as well outside of the loop something like thank you. So now let's try this out and execute. So now the system is asking very politely, do you agree, yes or no? The user might say, you know what, I don't agree. Now the system can ask again, do you agree, yes or no? And maybe the user says, you know what, maybe, I don't know. And as you can see, the system is keep asking because the condition over here is fulfilled. The answer is not equal to yes, and we will stay in this loop until we hear yes, until the condition is not anymore fulfilled. So now the system is asking for third time, do you agree? Well, this time maybe the user gonna be scared a little bit and say yes. And with that, you will get the thank you. And that's because we broke the loop. The condition is not anymore fulfilled. And we went outside and printed the thank you. So as you can see, it is very simple. All what you have to do is to have a looping variable like here, the answer. Then you build a condition on top of it, and then you make sure inside each iteration there is possibility to change the value. If you don't do that, otherwise you will be stuck in an infinite loop. Alright, so that's all about the while condition, the first type. Now we're gonna go to the second type, the while true. This one gonna be the most powerful, but yet the most risky. So let's dive in. We're gonna build it like this. We start with the keyword while, and then after that, we use the value, the Boolean value true. So there is no condition, no counter, no nothing. It's just the Boolean expression true. And inside the loop, we're gonna do something. So now in the chart, it's gonna be like this. Python gonna say, okay, while true. And this time we don't have like two answers. We are not checking anything. So we don't have a false and true. It will be always true. So there is no escape from this to the end. Now, if you just leave it like this and execute it, what's gonna happen? You will be stuck in infinite loop. So that's why we have to build somehow an exit in order to give it a chance to stop the loop. And in order to do that, we're gonna go and add a second condition using the if statements. For example, x is equal to the word stop. And if this condition is false, it's gonna go to the top of the loop. But if it is true, we have to do something. So think about it. What we could add here in order to exit a loop? Well, as we learned, we have the three statements in order to control the loops. And here we're going to go and use the break. It is our only chance to stop the loop. So we're going to go and include it inside the if statements. If it is true, the value is equal to stop. Then we're gonna go to the break and stop the whole thing. Now, of course, there are multiple ways on how to get a value for this variable, but we could ask the user for a value using the input function. So we ask the user for a value, and then we check this value using the if statements. So now let's see how Python gonna execute it. Python gonna start by the true, and here there is nothing to be decided. So it's gonna go immediately and enter the loop. So here it's gonna go and ask the user for a value. Let's say our user entered high. So Python gonna assign high for the x, and then go to the next step and ask about it. So is high equal to stop? Well, no. So we didn't get a stop from the user. That's why Python gonna go to the top of the loop and repeat the whole thing again. Maybe in the way we are printing or doing anything. So again, Python gonna see, okay, it is true, so I can keep going in the loop and then ask the user for another value. And here the user gonna give us the value go. And in the next step, Python gonna check it. Is go equal to stop? Well, it is not. That's why it is false. That's why we're gonna stay in the loop and then go back to the top after doing something. And here again, we have true, and then ask the user for again. a new value. Now finally, let's say the user says, okay, I am done, and give us the stop. So now Python gonna go and check, did we get stop from the user? Well, yes. Finally, we got the flag from the user that we are done. And with that, Python gonna go to the break and execute it. And this is the point where Python gonna say, oh, we have break, we have to exit, we have to stop everything immediately and end our loop. So as you can see, this is another way on how to build a loop. So you build an infinite loop and then you add to it an if statement together with a break, because this is your only chance to stop and exit the infinite loop. Otherwise, you're gonna stuck in a black hole. So my friends, this is very risky, but if you do it correctly, everything gonna be fine. Oh, I have to fix this first. So something like this. Okay, I know you want to try the infinite loop, right? But first, a disclaimer. Only run the following statements if your machine can handle it. So only if you have strong CPU, you have saved your work, and you are ready to restart your PC. So now let's go and build our infinite loop. So we're gonna say while true, and we're gonna print something like I am unstoppable. So something like this. And again, here warning, if you execute it, your things might crash. If you stuck with it, just eliminate it using the Control-C. Now I'm gonna try this out and I hope I will not break the recording. So we'll go. Now, as you can see, it is executing. So Control-C and stop it. And now it is stops, but I still hear the PC was not happy about it. Okay, so this is how we do the infinite loop. I don't know if you are still out there here, but I hope you are happy. Okay, now back to our task where we keep asking the user to type yes to agree with us until they do. Previously, we have solved it using the classical while with the condition, but this time I'm gonna go and solve it using the while true. So we're gonna start with the while, and after that we don't need condition, we will just say true double points. And by the way, make sure the first character is capitalized. And then after that, we go immediately and say we have a variable called answer. So that means it's not like before where we have like initialization at the start. We don't need that with the while loop, because previously we have the answer in the condition, and if you don't give it like any value, you will get an error. But here we are not checking anything yet, so that's why we don't have to define anything outside. And the same thing, we're gonna ask for an input. I'm just gonna go and copy this from here. So with that, we will get a value from our user, but we have to check it, right? Otherwise, it will not work. So in order to check it, we're going to use the if statement, and we're going to say if the answer is equal to yes, and then double points. So now, as you can see, this time we are checking whether the value is yes, not like here, right? Now, if the answer is yes, what can happen? We don't have to ask anymore. We got what we want and we break. So we break the loop and get out. And of course, we can put at the end like print. So we exit and get out of our while loop. And of course, at the end, completely outside the loop, we can say thank you. So now let's try this out. I will just go and comment this out and let's go and execute it. So as you can see, we are getting the same question. Do you agree? If you say no, you're still gonna get the same question. Maybe, I don't know. So with that, as long as we are not fulfilling this condition, Python will keep asking. So currently we are inside an infinite loop and we will not exit and break until we give the yes. So now if I go and give it a yes, it's gonna be happy and say thank you. So as you can see now, the system is behaving exactly like the while condition. And for this scenario, I'm going to go with the while true because it is easier to read. So we are building an infinite loop and we keep repeating that until we get the right answer. Okay, so now time to challenge you a little bit. Now I want you to extend the current loop with new requirements. The first one is to limit the user to 3 attempts in total. So if you don't get yes from 3 attempts, you don't ask anymore. If the user type yes within the 3 attempts, then you have to print the following message. Glad we are on the same page. But if the user didn't give us a yes within the 3 attempts, you have to print 3 strikes, you are out. So now pause the video, solve those requirements, and then we're gonna do it together. Okay, so now how are we gonna solve it? Now, as you can see, the first requirement is that we have to add like only 3 attempts. So now currently it is open-ended. We keep repeating the same question until we get what we want. But now with the new requirements, we have to make it limited. And with that, we can rethink about maybe we go back to the classical while condition. I know that we're going to iterate maximum 3 times. And for this, I'm going to say we go back to the normal while condition. So that means we're going to go and replace the true with the condition. And we're going to say as long as the attempts less than 3 times, you have to keep asking the same question. But of course, we have to do the step before the while where we do the initialization. So we're going to assign attempts to 0. So this is the initial value. This is our condition. And of course, what is missing, my friends, we have to make the updates. So for each iteration, we have to increase the attempts. And usually we're going to put it at the end before the next iteration. So we're going to say attempts plus equal to 1. So that I increased the attempts with 1. So with that, we made the 3 attempts. Now to the next requirement, we're going to say if the user did answer with yes within the 3 attempts, we have to print this message. So again, in our logic, what we are saying, get me a value from the user. And if the value is yes, then break. So that means this is a perfect place in order to print this message. So not only breaking out the loop, we would like to give this nice message where we can print, glad we are on the same page. After that, we break and then we increase the attempts. Okay, so now let's go and try this out. So now first, I would like to test whether the attempts are working, the new logic. That means the system should not ask me more than 3 times, not more than 3 iterations. Now I'm going to say no, then ask me again, maybe, I don't know, and now should exit. Exactly, this is what happens. We exit because we are not anymore fulfilling this condition. So we are exiting the loop normally without using the break. We had 3 iterations because the attempts were smaller than 3, but for the 4th iteration, the attempts were equal to 3 and 3 is not less than 3. That's why it is not fulfilling anymore the condition and we exited the while loop normally. Now let's go and test whether this is gonna work over here. If we get yes, it's gonna break and give us this message. So let's say for the first one, it was no, but for the second one, we have yes. As you can see, the system didn't ask us for a 3rd time because we fulfilled this condition inside the while loop. The answer from the user is yes, and we fulfilled this condition. That's why we entered to this block where Python printed the message and then executed the break. So that means the while loop stops because of the break, not because we are not fulfilling the condition anymore. So we didn't exit normally, we exited using the emergency break. Okay, so now let's talk about the last requirement. Otherwise, we have to print this message, 3 strikes, you are out. That means if I'm not getting yes, we should print this message. Well, you might say, you know what? Let's go and get this one instead of the thank you. We don't need the thank you anymore. And if we didn't exit with the break, we will get this message. Okay, so now let's try this out. I'm gonna say no, no, and no. Now, as you can see, it is working. So we are getting, okay, 3 strikes, you are out. We didn't get a yes from you. But my friends, this will not work if we have a yes. So let me show you what I mean. Let's say, okay, first time no, but the second time we say yes. Now we have an issue. We have the 2 options together. So it is saying, glad we are on the same page, and this came from here. But at the same time, it says, yeah, 3 strikes, you are out. Well, this is not exactly what we want. It is either we are happy we are at the same page or you are out, not both of them. And that's because we have this print completely outside the while loop. So after we broke the loop, the next instruction in Python gonna be the print. So this is gonna be executed whatever happened in our while loop. But my friends, I would like this to be executed only if we didn't break. Now think about it. What we have used in the for loop in order to print something didn't break. Well, we have to go and use the else statements. And yes, we can use else together with the while, not only for the for loop. So let's go and add that. We're gonna say else double point and then put this print inside it. So that means if the loop ended normally without a break, this message can be printed, but if Python executed the break, then Python will not execute the else. So either we exit normally and execute the else, otherwise we exit with emergency using the break. So now let's try this out. The first one gonna be no, then the second one we're gonna say yes. So now, as you can see, we are getting now only one message. Glad we are on the same page, and this came from the break. That means we fulfilled this condition and Python printed the message, executed the break, and with that we exit immediately from the loop without executing the else statements. And we can do the last test where we have never given a yes. As you can see, now we are getting the 3 strikes, you are out, and this came from the else statements. So as you can see, we can use the other control statements like the break, pass, continue, the else statements in order to build our logic and control exactly how our loop gonna behave. So now if you compare the two types side by side, you can see with the while condition, we know when the loop should stop. We have like something limited that gonna end the loop naturally. But with the while loop, it's gonna run forever. It is infinite until something happens, until an event triggers the stop. So that means with the while condition, things can end naturally, but with the while true, you have always to add extra stuff like a condition using the if together with the break. This is your only possibility to stop the loop. And if you are talking about the risk of having infinite loop, the while condition, it is safer. Eventually, it's gonna exit unless you made like a big mistake. But with the while true, it is more risky because you are defining an infinite loop and you have to be careful designing the if and the break. And as we learned, the best use cases for the while condition, if you are building like a counter, or you are building a limited retries, or you are validating the output from the user. But on the other side, we use the while true if you have an open-end scenario and you are trying to get a trigger from something external, like you are trying to connect to database, to stream, to APIs. So at the end, I'm gonna say always try to build things using the while condition, but if you want something more advanced, more flexible, something that is open-ended, then you have to use the while true. But be careful how you build it. Now we're gonna compare the two types of loops, the for loop and the while loop side by side. With the for loop, you need a sequence where Python gonna go and create an object called iterator, but with the while loop, you don't need anything like that. And for the for loop, Python gonna build like predefined condition. It's gonna ask always, are we done with the sequence? It's not something that you change, but with the while loop, you are totally flexible. You can add your own condition for the iterations. Now about when to use what, we use the for loop if we know already how many times we want to loop. And as we learned, we use the for loop in order to go through our data to do something, like we loop over the rows, the tables, the columns, the files, in order to clean up or prepare the data. But now, in the other hand, with the while loop, we use it if we don't know how many times we want to iterate. We are waiting for an event, a trigger, a condition. So we use it if you are building like retries in the login, or you are trying to connect yourself to a database or APIs. Now, the advantage of using the for loop is that it is simple, clear, and it is really hard to make an infinite loop with the for loop, so it is really safe. But of course, it is limited. You have always to predefine how many times you want to iterate. But on the other hand, with the while loop, it is more advanced, more flexible. It adds dynamic to your logic, but it is complex, and you have a high risk of building an infinite loop. So at the end, think of the for loop as like you have a playlist. You know exactly how many songs you have, and the while loop, you are waiting for a reply. You keep checking until the condition is met. So that's all about when to use what. Alright friends, so with that we have learned everything about the while loop, and as well we have learned everything about how to repeat a code in Python and all the use cases, why we do that. And with that, we have covered everything as well about the whole control flow. So with that, you are not anymore writing a code that is a straight line. We are making some complex logic. You are controlling the flow, the logic on how your code is executed using the conditional statements, the if else, else if, and as well how to repeat a code using for and while and all the different shapes and designs in each type. So with that, we have covered everything in this section, the control flow. And next, we're going to speak about something very important, especially if you are working with data. Finally, we're gonna learn the modern data types, the data structures. So if you like this video and you would like to have more free content like this, then support the channel by subscribing, liking, commenting. This really can help the channel to grow and to reach others like you. So thank you so much for watching, and I will see you in the next video.